Okay, so you have an absolute value equals an absolute value. Okay, so if you remember, absolute value of x equals absolute value of y just means that x can equal y or x can equal negative y. Okay, so if we apply that same idea to our problem, means absolute value of 5x plus 3 equals absolute value of 3x plus 5. So make that look more like an absolute value. Okay, so we know that means, so if this is our x and this is our y, that means that 5x plus 3 equals 3x plus 5, or, I'll put that down here since we're running out of space, 5x plus 3 equals negative 3x plus 5. Yes.
Okay, so when you put the negative, like the negative y, so the negative only applies, and put it in parentheses.
Yeah, so it applies to the whole thing. Okay, so if we go ahead and solve both of those, so 5x plus 3 equals 3x plus 5, and 5x plus 3 equals negative 3x plus 5. Okay, so if we go ahead and subtract 3 from both sides, we have 5x equals 3x, negative, well, 5 minus 3 is 2. So if we subtract 3x, 5 minus 3 is 2, so we have 2x equals 2. Divide both sides by x, so x can equal 1. Okay. Now for the other side, we just have to distribute our negative first. So that gives us 5x plus 3 equals negative 3x minus 5. So we can subtract 3 from both sides. So we have 5x equals negative 3x minus 8. So if we add 3x to both sides, we have 8x equals negative 8. So dividing both sides by 8, you get x equals negative 1. And you can check it if you like. Again, you don't have to check it. All right, so any questions on that one? Okay, so that's if we have an equal sign. Now we're going to look at our inequalities. So I'll leave that up for a few more seconds. All right. Say we have our inequalities. In the form of absolute value of x is less than k, or absolute value of x is less than or equal to k. Pretty much the same for both of them, just differ by the less than or equal to. Okay, so we're going to have the same idea that we have for absolute value. So if you remember, let's say absolute value of x equals 5. It just means that the distance from 0 is 5. So that x could be -5 or +5. Okay. But instead of an equal sign, what if we threw in a less than sign? Okay, so that means the absolute value of x is less than 5. That just means that the distance from 0 is less than 5. Okay, so if we drew out a number line, and we started at 0, and let's say we go 1, 2, 3, 4, 5, and -1, -2, -3, -4, and -5. Okay, so if we started right here from 0, and we go all the way here, and we don't include 5 because it's just less than, every value in here could be your x. Because you plug in 3, absolute value of 3 is less than 5, which is true. If you plug in 4, absolute value of 4 is less than 5, which is true. The only thing you can't plug in is 5 unless you have less than or equal to, because the absolute value of 5 is not less than 5, it's equal to. Okay. Same thing with -5. If you go all the way in this direction, everything in here would make absolute value of x is less than 5 true. If you plug in -4, absolute value of -4 is 4, which is less than 5. Absolute value of -2. That's just +2. 2 is less than 5. So all of those values from here to here would be true. So any value here is less than 5 units from 0. And we use units because we don't know if it's inches, feet, miles. So we just use units as kind of an open unit of measure, or an open measurement. Okay, so if we look just at this, that means the absolute value of x is less than 5, means that x is greater than -5, because it's -5 here, it's greater than that, and, that's the key part, x is less than +5. Okay, because it's always going to be bigger than -5 and less than 5, so it has to be in between both. Okay, does that make sense? All right, so this is going to give us kind of a general formula like we had before. So in general, if we have the absolute value of x is less than k, that just means that x is greater than -k, and x is less than k. Or if you wanted to, you can write that as what they call a compound inequality, where you can put both of those into one. So you have -k is less than x is less than k. So really that just means that any value of x is between -5 and 5. So that just means any value of x is between -k and k.
So for the negative value, x will be greater than the negative value?
Yep, it'll be greater than the negative and less than the positive.
Okay, so like on the scale,
Mm-hmm.
I think you put the wrong sign, maybe?
For which one?
For the absolute value of -5 on the other side.
No, this one?
Yeah.
Oh, we just have the general absolute value of x is less than
I
5.
see.
Yeah,
I see.
that's why we didn't.
That's the general value.
Yeah, that's
Okay,
just the
okay.
general idea.
Okay.
All right, so I think it's just the exact same thing for less than or equal to. The only difference is you just had an equal to underneath it. So absolute value of x is less than or equal to k. This means that x is greater than or equal to negative k, and x is less than or equal to positive k. Or if you wanted to write it as a compound inequality, x is between negative k and k. So you have negative k is less than or equal to x less than or equal to k. So really those are the same, so you only have to remember one of them. You don't have to remember both. Alright, so let's say for our first example, we wanted to solve the absolute value of 2x minus 3 is less than 9, and we wanted to graph the solution set. And graphing the solution set takes about 3 seconds. All right, so if we have that, okay, so you want to remember you have a less than, so you want to use your less than formula. That means the absolute value of x less than k means that x is greater than negative k. And x is less than k. So if we apply that to this problem, we end up with the absolute value of 2x minus 3 is less than 9. Means that 2x minus 3 is greater than negative 9. And 2x minus 3 is less than 9, positive 9. Okay. So just like before, we go ahead and just solve for both. Okay, so if we have 2x minus 3 is greater than negative 9, and 2x minus 3 is less than 9. And solving inequalities is the exact same as solving equations. Add 3 to both sides. So you have 2x is greater than negative 6. Divide both sides by 2. You have x is greater than or equal, greater than negative 3. Okay. Now if we solve the other one, if we add 3 to both sides, those cancel out. So you have 2x is less than 12. Bring that down a little. Divide both sides by 2. You have x is less than 6. Okay. Now to graph the solution set, you literally just need a number line. Okay, so let's say this is our 6, and this is -3. Because you have less than and not less than or equal to, you're going to use parentheses. So you're going to have parentheses here, parentheses there, and everything in here is shaded. Okay, so this is your graph of your solution set. All right, does this make sense? Graph of solution set. Okay. And remember, if you had greater than or equal to or less than or equal to, you would use the brackets, square brackets on each one. All right, any questions on this one? All right, I'll leave this up for a few more seconds. All right, so let's say for our next example, you wanted to solve absolute value of 4x minus 5 is less than -2. All right, now I'll give you a few minutes to start on this one. If you're running into trouble in this one, there's a good reason for that. This is actually kind of a trick problem. Remember, the absolute value of anything is positive. So it's no possible way the absolute value of anything could come out to be a negative number. So that's why with this one, there's no solution. So it's kind of a trick problem. So if you see the absolute value of anything being less than 0 or a positive number, or a negative number, it's automatically no solution. Since the absolute value of anything is positive, there is no value for x that will make that less than negative 2. Or less than negative 2. So your answer is actually no solution. Okay. So sometimes you'll see it written as your solution set. Okay. Which claims an empty set, which means there are no solutions. Empty solution set. Simple. Okay, so when you see that 0 with the slash through it, that just means no solution. All right. So any questions on that one?
Since the absolute value of anything is positive.
Mm-hmm. Yep. So it's nothing we can plug in for x, because whatever we plug in for x, it'll always come out to be the absolute value of that number, which will be positive. So if you plug in 0, the absolute value of negative 5 is 5, so 5 isn't less than negative 2. If you plug in negative numbers, you'll still get a positive. If you plug in positive numbers, you'll still get a positive. So no matter what you plug in, you'll always get a positive number. Okay, I'll leave that up for a second. Okay, so what if we had an inequality in the greater than? Solving inequalities. In the form of absolute value of x is greater than k. Or absolute value of x is greater than or equal to k. Since they're pretty much the same. Okay, so just like before, we're going to go back to our starting idea. That absolute value of x, let's say if it equals 7, that just means the distance from 0 is 7. Either it's positive or negative, if we're in there. It means the distance from 0 is 7. Okay. That's all the absolute value means. And remember that x is less than 7 just means the distance from 0 is less than 7.